在这个产品上年给了省300万。
This is Mr. Xu, founder and general manager of Taicang Hongrui Metal Parts. Across manufacturing industries, both in China and globally, cost reduction remains a constant goal. But sustainable cost optimization comes from engineering decisions rather than commercial pressures. Hi, I'm Honggang. Welcome to Gimba Geek. Many of my friends and peers run factories or engineering companies. Each of them solves a specific problem in the field. I visit them to understand the methods and to share what manufacturing looks like on the ground. Today, we are at Taicang Hongrui Metal Parts. It's May 2nd, during China's Labor Day holiday. The factory is quiet in the middle of an empty workshop. Mr. Xu and I sat down to discuss how cold hurling can influence the cost structure and precision of metal components. Cold hurling is a forming process that reshapes metal under pressure without removing material. Compared with traditional machining, it produces nominal scrap and ensures higher dimensional stability. For many components, this approach reduces material use by 20 to 30% and improves consistency between batches. It's particularly effective for high volume or repetitive parts where geometry and tolerances are standardized. One of the examples discussed with the eccentric shaft used in transmission systems. If the entire shaft is cold hurled in a single step, the thin eccentric section tends to deform, resulting in dimensional deviation. To address this, the team cold hurls only the main body. They machine the eccentric column separately. This hybrid method stabilizes concentricity and improves the visual finish while lowering total cost. Another case involves stainless steel, mainly 304 and 316. These materials are strong and prone to work hardening, making them difficult to process on lathe. Use cold hurling for base shape and machining only the critical features, reduce production time and tool wear, allowing stainless steel parts to be produced at a cost level closer to carbon steel. A notable project is a plum blomsom gear used by several European customers. Hongrui redesigned the forming method. The gear teeth, outer diameter, and the square base are now shaped in a single cold hurling cycle. Dimensional accuracy in cold hurling depends heavily on mold design die filling. When the cavity is completed filled, tolerances can reach 0.03 to 0.05 millimeters. Hongrui continuously reviews its tooling designs to minimize deformation or uneven edges. In one case, the team spent several months modifying the die geometry to stabilize part filling. This reflects how incremental adjustments in tooling directly affect final precision and process repeatability. The result of these engineering improvements is measurable cost efficiency. The annual projects that save 3 million RMB per year illustrates the cumulative impact of multiple small optimizations. Shorter cycle times, less scrap, and reduced downstream rework. Such outcomes often deliver more value than conventional supply price reductions. Cold hurling is not a new technology, but its combination with modern machining and tooling design continues to expand what's technically and economically feasible. This visit to Hongrui provides a clear example of how process integration, not just automation, creates real value in manufacturing. Thanks for watching. See you next time.